Hey everyone, I'm Siddharth and you're watching Sciencefully. This is one of my absolute favorite science toys. It's Newton's Cradle. I actually ordered a new one for the purpose of this video and I have not opened it yet. So I'm going to do that right now. If you don't already know about this, don't worry. I'll explain what this is and how it works. Alright, the purpose of this apparatus is to demonstrate the law of conservation of momentum and energy. The modern version of this toy was not created by Newton, but like countless other things, it was named after him, as it uses his laws. So let's see this thing in action. This is the principle of the law of conservation of momentum. Momentum is the property of an object due to its motion. It is given by the product of an object's mass with its velocity. Velocity is just the speed with a direction. Momentum is represented by the letter P and has the SI unit kilograms meters per second. So we can say P equals mv, where P is the momentum, m is the mass, and v is the velocity. Now what is the law of conservation of momentum? The law says momentum of a system remains constant unless an external force is applied. Mathematically, it is written out as P initially equals P finally. The Newton's cradle works on collisions. So let's have a look how conservation of momentum applies to collisions. Let's number the balls 1 to 5 from your left. Ball 1 is displaced and then left. It travels down and hits the second ball and stops. The velocity of the first ball goes to 0. Now if the momentum of the whole system as a whole is to remain the same, the second ball must take off with the same velocity. Let's be quantitative here. Say the mass of each ball is 0.2 kilograms. The first ball inherits a velocity of 2 meters per second before colliding with the second. Its momentum equals 2 times 0.2, which equals 0.4 kilograms meters per second. Now the ball collides with the second ball and stops. Its momentum now 0.2 times 0 equals 0, as the velocity is 0. Now if the momentum is to remain the same, the second ball must possess the 0.4 meters per second momentum. And to do that, it must have a speed of 2 meters per second. This cycle goes on until the last ball takes off. Then it repeats. I did the math and the equations confirm that if two bodies with the same mass collide while one is at rest, the velocity is transferred exactly. Not more, not less. And this is the reason why this toy actually works. Also, I must point out that everything I have done in this video is assuming that there is no loss of energy in the form of heat, even though it's not the case. It's very close to a perfect collision where no energy is lost in the form of heat, but not exactly. That is all for today. I'll see you in the next video. Thank you for watching.